Hello everyone. As I promised, I would like to create a video about this particular theorem. So, the theorem states that the limit as x tends to 0 for sine of x over x, this will be 1. Now, this theorem, we will be using another theorem to prove it, which is the squeeze theorem. And I assume that most of you know and recognize the theorem. But if not, then I might read out loud to present the proof for this particular theorem. Now, sorry, let me give me a second to find the definition. I would like to present it very nicely so that there will be no errors on my explanation. So, give me a second to find that particular theorem. So, where is it? Mm, um, squeeze. Oops, I can't find the squeeze theorem, unfortunately. Um, but anyway, but I assume that most of you know the theorem, which is the squeeze theorem. So first things first, we have to know those three functions where it's between one another. Basically, in a nutshell, I would like to show that there's a function between two functions. So let's say the function h of x is less than f of x is less than g of x. And all of these functions have to be continuous. You know, mm, I really need to see the correct definitions that I could explain it properly. I'm very sorry if it seems rushed a bit, but 83. Where's the squeeze? Limit sine theta. Yeah. Oh, sandwiched. Oh, it's 2.2. Okay. Ah, here it is. So there are names for it. You can call it as sandwich theorem or squeeze theorem. Well, basically, we have three functions, right? And let's say there's a value of x in some open interval that contains c. So here we argue that for the limit, as x approaches c for h of x, if it's equivalent to the limit x approaches c, g of x, when it gives us a limit, a real value, then by the theorem itself, we know that the limit as x approaches c for f of x, this will be L as well. So that's basically informal explanation for the limit, which is the squeeze theorem, or some books call it as the sandwich theorem. Nonetheless, it's the same theorem. Anyway, now the question is, what will be the functions that we will be using to find the value of the limit? Okay, so let me draw a unit circle, then we could derive the functions from there. Now we have to draw a circle. Let me make it bigger so that everyone can see what I'm trying to draw. Okay, like this. And now we know unit circle means that the distance between the origin and the intersection here will be 1 unit. And then we will create a triangle. And by the way, the x values I'll be using between 0 up until pi over 2, right? I restricted there. And yeah, so first I create a triangle right there. And then I'll be creating, okay, I have to draw the bigger triangle first. Okay, let me draw a line here, over here. Okay, I'll let this as x. And then this, at this point, will be 1 tangent of x. then this point will be, if I'm not mistaken, cosine. If I am not mistaken, it should be, yeah, it should be cosine. So here will be cosine of x. Let me draw it properly. Cosine of x, sine of x, that particular point. So now what will be the functions? Well, it's basically we obtain the area for three regions. The first region will be this big triangle. Okay, that will be our first region. And then, okay, let me write down first. So the first region will be the area of the triangle. So 1 over 2 times 1 times with the tangent of x. Okay, therefore, our first area will be the tangent of x over 2. And then, what else? Now, I'll be obtaining the second area, which is this sector right here. So this sector, remember, the x value is in radian. Therefore, we'll be using the formula for sector, which is A2 is equal to um, 1 over 2, yeah, 1 over 2 r squared theta. So our theta will be x and our r will be 1 because the radius is 1. Therefore, we will obtain x over 2. So that will be our second area. My gosh, no. Let me rub this part off. Okay. And then our final area that we need to have is, it's a bit tricky, but let me draw here. So when you realize this is a triangle and the height of it is sine of x and the base will be 1 like this. Therefore, therefore, the area will be 1 over 2 times sine of x times with 1. And we will obtain the final one will be sine of x over 2. Now, as you can see, the first area is the largest. So we will write the inequality as given. Tangent of x over 2 will be the largest. And the smallest area we have is sine of x over 2. So you will locate it here. And then the area between those two areas will be the sector, which is x over 2. Now, our goal here is to create this inequality and make sure the function in the middle will be sine of x over x. That's our goal. So how do we obtain that goal? First things first, I would like to get rid of the fractions here. So the way we want to do it is by multiplying both sides with 2. Therefore, we have tangent of x. X is largely equal to sine of x. And now we are left with this. So, oh, by the way, the reason why I restrict the domain is because that if I multiply, if I divide both sides with sine of x, then if I don't restrict the domain, then the values will include the negative values as well. So the inequality sign will change. Therefore, I let the domain to that kind of value because it is only on the first quartile, the first quartile meaning that quadrille, whatever, means that the value will always be positive. It doesn't affect my inequality here. Therefore, I restrict that domain. Anyway, now, first let me convert tangent of x, express it in terms of sine and cosine of x. And now I'm left with this. Now, the way we want to do it is divide both sides with sine of x. It doesn't affect our inequality anyway because we already restrict the domain. So we are left with this. All right. Now, to obtain this, we flipped the fractions given, but the consequence is that the signs of inequality will change as well. Therefore, we will obtain cosine of x less than equal to sine of x over x less than equal to 1. So now, to obtain the limit as x tends to 0 for sine of x over x, we will be using the theorem that I mentioned, which is the squeeze theorem or sandwich theorem. So how do we obtain it? Well, first we have to evaluate the limit for cosine of x and 1. So as x tends to 0 for cosine of x, you obtain 1, and this is equivalent to as x tends to 0 for 1. Since 1 is a constant, it doesn't change anything. So by theorem, by using, by using, squeeze theorem, squeeze theorem, or sandwich theorem, whatever you want to call it, as x tends to 0, sine of x over x will be 1. So there's your proof. I don't know, is this a valid proof? Because the way I wrote it is very informal. It isn't properly written as a true mathematician. But it's just a way to explain on how we obtain this theorem by referring to the previous term, which is the sandwich theorem. Okay. So yeah, I think that's about it from me. Hope you guys do learn something about today's video. And if you haven't, check it out, please. Check out the previous video, which is about, well, the integral is a very interesting integral. Okay, so that's all for me, and I'll see you later. Bye bye.